Thank you for the introduction. I'm going to talk about the current status and the current deployment of BECCS. So first of all, what is BECCS? Very simple, just to get everyone introduced to this topic. Well, BECCS is, as Chris mentioned, bioenergy with carbon capture and storage, and it goes under many names. I prefer to use BECCS because it's established in the IPCC terminology. And eventually it's the opposite of fossil fuel emissions that you could create, the negative emissions. Very simple, how does it work? As all of us know, CO2 is involved in the carbon cycle, and this has been going on for billions of years through photosynthesis and respiration. But we as humans are involved since hundreds of thousands of years, since the first campfires. And nowadays we do everything from paper to electricity, combined heat power, etc., from biomass. So we already have a lot of biomass energy systems installed. And if we add a CCS component to this, we will actually have a flow of carbon from the atmosphere through biomass and industries into the subsurface. And this is BECCS, and the result is, as you can see, a net removal of CO2 from the atmosphere. This is very simplistic, of course, and as you mentioned, we will have to look very carefully into different system modeling of biomass, of industries, of storage, etc. But it's a very promising technology, and it has started to get included in all of the scenarios that, for example, are going to be part of the IPCC fifth assessment report. And here is a very simplistic comparison. The problem that we have is that we mine a lot of carbon in various forms, coal, natural gas, oil, and release it to the atmosphere, increasing the amount of CO2 in the atmosphere. We can do, of course, CCS, for example, at coal-fired power plants, but this will never bring down the CO2 in the atmosphere, and neither with a simplistic model of bioenergy use if you don't, for example, increase the amount of standing biomass. Though by combining, so to say, the best of CCS and the best of biomass, we can actually have a removal, a negative minus from the atmosphere. So this is on your right-hand side, it's the very simplistic model of BECCS. Why do we need BECCS? Well, you mentioned at least four very, very good reasons for BECCS and negative emissions. And very simply put, BECCS can mitigate previous emissions and emissions from any source. I think it's very interesting, this notion of actually having BECCS in one place and then emissions in another place and them outcreating each other, such as with the airplanes on fossil fuels and bioelectricity with CCS. We can also, of course, mitigate already emissions that have already occurred. And this is a unique property for BECCS. Then we can also have a historic emission risk management tool, something put forward by, for example, Obersteiner in his science article in 2001 that kind of launched this topic into the research community. And we could also look upon BECCS as something that could be added as a supplement on already existing biomass, so something that strengthens the biomass system. Yeah, this is very simplistic model of the amount of carbon dioxide in the atmosphere. It's taken from Reed and Lermit. And right now we're following this blue line. And interestingly enough, not even the Kyoto line will bring us into a safe pathway. And not even a green line, as this graph shows, is enough to reach ambitious targets such as 350 ppm. Because we're already now at 392 ppm of carbon dioxide in the atmosphere, and we are actually heading on the blue line. So even going into a totally fossil-free or emission-free scenario like the green line will place us in a situation where we are above safe levels of carbon dioxide in the atmosphere. So according to Reed and Lermit, if we would combine a very robust green line with BECCS, we could actually achieve a yellow line here and return back. And this is also what you showed in the for example, the image line in your last picture. So this is, I think, the most compelling part of BECCS. And if you look at the recent research in this area and the policy discussions, the IEA has been very interested in this, since, as Fatih Birol says, that the very famous 2-degree target is now extremely difficult to meet. And even a 450, as you see in this second quote here, even a 450 ppm target will be extremely difficult to meet without negative emissions. So how does it look on the ground? Well, we're fortunate enough to actually have the first BECCS demonstration in place already. It's a large demonstration in Illinois, funded by the US Department of Energy. And it's a big, big group with 46 partners, of which we are one at Biorecro. And it will scale up from the current 300,000 tons per year to 1 million tons per year of CO2 injected. So this is actually a full-scale demonstration. And for being a BECCS demonstration, it's very large, since biomass plants tend to be smaller, about 1/10 smaller in size than coal-fired power plants, for example. There is also a possibility to combine this with novel and emerging energy technologies. For example, if we would want to follow the bioelectricity pathway, it's very interesting to be able to gasify biomass and to do other electricity and perhaps even other fuels from novel technologies for biomass conversion. So we have looked at a possible pilot study combining gasification or third-generation biofuels with a CCS facility in North Dakota, also as part of the US DOE effort through the EERC at the University of North Dakota. This would be a very small pilot compared to this one. This is 3 powers of 10, almost smaller, but it's very interesting because it would be the next generation technology. And here is a pilot in Kansas. And just to show you it's real, it's actually me sitting there by a completed wellhead. And I think he looks very much like me today. It's the same suit even. And this one is the completed well for injection. And another 200 yards away, there is a monitoring well already in place. So this will be combined with a nearby ethanol plant, and 40,000 tons will be stored through both a EUR as well as a saline aquifer operation. And startup is already 2013, and 1 year is very short in this type of project. So this is another opportunity for looking at these projects. Here is a map of all the projects that we found in a search 1-2 years ago in front of the Cancun COP meeting. So here you can see there is predominantly 3 different technologies: pulp and paper, ethanol plants, and gasification and other technologies, so next generation conversion. Unfortunately, a lot of the plants is, of course, in the United States and North America, as well as Europe, especially Western Europe. And there is very little activity in some key areas for BECCS deployment, especially Africa and South America. So it's going to be really interesting to hear the next talk on this, because, for example, Brazil is very promising for BECCS deployment. And here's a project list. 3 of those that you saw in the last picture are actually in operation, one of them being in the Decatur plant that I showed a picture from. And then we have one actually that's already completed. The University of Kansas made a small pilot last decade that they completed with interesting results, and they are available. So here you have the guys who are waiting in the queue. Of course, there is way too little activity here because of current carbon policies and the economic crisis, etc. But the real challenge now is, of course, to push more projects from the preliminary stages into the green stages here, where we have actual deployment, instead of pushing them down here where they will be canceled, as you may notice here. So this is the short-term challenge. And there are lots of problems, unfortunately. This is, of course, no news to you, but the carbon price is now way too low to even come close of incentivizing the technologies that we're discussing today. There are some opportunities that we pursue at Biorecro, but they are small scale compared to the challenge. Then there are some institutional challenges, and workshops such as this are a great opportunity to overcome them, spreading knowledge about these technologies, getting both fundamental researchers all the way up to policy makers to be involved into this discussion. And there is a set of issues such as biomass accounting, the ILUC discussions, etc., that feed into the BECS systems and make them even more complex to analyze and to do research on and get good results. So essentially, it's a blurred view, and it's because of baselines and all of these issues that I mentioned. And my hope is that, of course, the research community will now address more and more of these questions. And it's coming more and more research. So I think this is on the way to overcoming the initial barriers to establishing a vibrant discussion on this globally. Here is another scale-up issue. Right now, the projects which I showed are a couple of 100,000 tons a year. And if we are to follow the IEA roadmap for CCS, we will need to scale from a couple of 100,000 tons per year to 36 million tons a year in 2020. That's a very big scale-up. It hasn't started yet, and we're already 2 years into this decade. 2020 is very close. Building one of these projects takes 2, 3, even 4 years. So this is a major challenge that I am very involved in. And of course, a lot of the discussions today, we're going to look at the 2050 target. And the bad news is that when we compare this amount, the 36 million, it dwarfs to the 2050 target. And this is not a small issue. The amount of institutions, the amount of incentives, the amount of industry capacity that we need to build up, we have to scale it exponentially many times over. So this is a real challenge that we shouldn't underestimate. And of course, it's important that we start now here, and also that we have a good site and a good plan for achieving the 2050 targets and actually reach those large-scale global negative emission systems that are needed for conservative targets, that is, ambitious targets. We have the issue of sustainability of biomass, and I think there are a couple of talks on this today, so I will not speak a lot about it. I would just want to point out that it's not black and white, it's grayscale. There is good, there is less good, there is okay, there is bad, and there is very bad biomass supply system. So it's important that you take a close look at each and every system, rather than say, oh, this will drive that, and etc. So one of the issues, of course, is if we have a biomass energy system, if we apply BECS on it, how will that application drive land use change, for example? Quite difficult, not very easy to understand. And I'm looking forward to discuss that in the breakout sessions this afternoon. It's not only problems, there are actually some opportunities out there. So one is, of course, that you have already a lot of facilities in place, such as the pulp and paper plants I mentioned. And there are many other applications. Power plants, combined heat and power plants, ethanol production, biogas upgrading, gasification of biomass, novel technologies, perhaps including algae, etc. So there is a lot of different technologies. So BECS is not one technology, but 20 times 20 technologies, because then you also have different storage technologies, etc. So this is an area rather than only a niche. One of the most interesting early opportunities, I would say, is ethanol industry. Mainly because you will have a very pure stream of CO2 coming out of an ethanol fermenter, 99.99% pure in many cases. So it's zero capture cost, and normally capture costs are the largest parts of a CCS system. So you could get a very low cost and quite high volume amount of CO2 from an ethanol plant, typically 50 to 300,000 tons of CO2 per year. And as I showed in the Decatur example, which is one of the largest ethanol plants in the world, you can actually even have 1 million tons per year stored. There are all of the projects currently operating are with CO2 from ethanol plants. And there are two more, like the one in Kansas where I was kneeling at the wellhead. They are also ethanol. And there are, only in the United States, there are around 200 ethanol plants in operation. And there is hundreds and hundreds more in Brazil, for example. There is even one in my home country, Sweden. So that's I would say, the ethanol industry, even though it's not optimal from an energy perspective, and especially not from a primary energy to energy use perspective, it's very interesting to start with those ethanol plants to get the BECCS technology going. You will also find 300 million tons, and more than that, of biogenic CO2 emitted from pulp and paper plants every year. And this is quite a lot. This will contribute typically a tenth of the capacity, even in very ambitious BECCS scenarios. And this is already in place. It's emitted every year. That's 1 million tons a day almost. So this is a major opportunity. And these plants do not have this very nice pure CO2, but they have a lot of it, 500,000 tons to 2 million tons a year. Yeah, the last 5 minutes or so, I will talk a bit about BECCS in Sweden, where I come from. There are a couple of countries, of course, that have better opportunities for BECCS, especially the ones that have a lot of biomass, such as Sweden, Brazil. Even in, I would say, United States is a very good country for doing BECCS. Canada, et cetera, et cetera. So BECCS in Sweden, if you look at the Swedish emissions per capita, they're very low, and we're not that many people. So in 2010, Sweden emitted 65 million tons of CO2, okay? Mainly from transport sectors, because the electricity sector is very lean on carbon dioxide, mainly being powered by hydro and nuclear. But in addition to these 65 million tons, we had 31 million tons of, so to say, clean or biogenic CO2 emissions that are not part of the carbon addition to the atmosphere, since they are part of a renewal carbon cycle. So we have 61 major emitters of this biogenic CO2, and they are distributed throughout the country. This one is Sweden here, Norway here, and Finland there. And they're distributed among the, here quite evenly, but up north where we find the really large plants, you have biomass here in the middle of Sweden, and then it's transported down to the coastline, turned into the papers that people are writing with in Europe, and then the CO2 here could actually be captured at these plants and shipped to Norwegian storage sites. Everyone who is involved into CCS will think, oh, that's expensive. And yes, it's expensive, but it's much cheaper than many of the things that we do right now in Sweden to mitigate carbon emissions. Sweden has one of the, if not the highest carbon tax in the world right now. So if I go out with my car, which I don't have, but if I go in a cab, for example, the cab driver has to pay $150 per ton of CO2 in a carbon tax. That's quite a lot of money. And these systems typically cost $100 to $110 per ton, even including this shipping, which is hundreds of miles. Because you need to ship here because essentially Sweden has no sedimentary rock because of the ice ages. So you have to go to the Norwegian fields here, which coincide with the Norwegian oil fields. And here at Utsira, for example, we have one of the examples of a megaton multi-decade storage site. The Sleipner, perhaps you've heard of it. And even up at Tubåsen there, you have at the Snövit plant, you have a CCS operation already in place. So there are very good opportunities. And if you put the mitigation cost at or below 1,000 kroner per ton, which is about $130 per ton, which is below today's tax, please note, you will find that BECCS could make an enormous contribution. CCS, especially on industrial sources, could make a big contribution, and all other sectors are quite marginal, going from the 65-something tons to 21 tons in 2030. And we could even go carbon negative as the first country in the world, not only cutting our emissions to zero, as is the vision and plan of the Swedish government right now, but going below and way below into a carbon negative situation where Sweden would remove CO2 from the atmosphere. So this is my presentation. I'm looking forward to questions.
Questions for Henrik? You can pick, unless you want me to.
Please, in blue shirt.
Okay. Thank you. You suggested that Sweden's aiming to go carbon negative perhaps by 2030 using BECCS. I'm wondering if you factored into that calculation, if you're using Norwegian oil fields with enhanced oil recovery, the additional carbon emissions from the oil which is removed from those fields.
Well, actually, they have made a lot of EOR, as it's called, enhanced oil recovery. I think that was what you meant, injecting CO2 to get more oil out. And it has not proven very lucrative in the Norwegian oil fields. They are not as the Permian Basin oil fields in Texas, West Texas. So this would actually be for saline aquifer storage. It tends to be very difficult also to do EOR at those offshore fields compared to onshore fields. So no, it's not with EOR in this situation. Please.
You had a slide that mentioned a barrier of bad accounting. I think you meant bad carbon accounting. I was wondering if that brings to mind to you any projects or technologies where bad carbon accounting makes something that should be good look bad, or vice versa.
It's an interesting question, but this is not my focus point. So this is not my area of expertise. But of course, it's a lot of politics in carbon accounting, and especially in this ILUC discussion that ubiquitous, I think it's a lot of politics rather than only science.
Let's just say that biomass is an area that's rich with bad accounting, and it has some examples of very good accounting too.
Exactly. And that's also, it's not black and white. You can find everything. Please.
Can you please clarify about how the BECCS is accounted for in the clean development mechanism? Like, do they count it as only one emissions, or do they double count it because you're having negative emissions?
It's not even part of the CDM or Kyoto mechanism at all. CCS have had a very hard time to make its way into these mechanisms. And if you want to have BECCS, that has to be add on to the kind of policy structures and regulations that you have for CCS. And it was not until the very last COP meeting that this was accepted at all. So unfortunately, BECCS has a very long road to go. And that's what I mentioned with institutional challenges. This is not part of any international negotiations right now, unfortunately. So we have a situation where the scientists on one side that do the climate mitigation modeling say, we need this really badly. And then we have the policy on the other side that say, what's this? They don't even know about it, and they don't work with it. So that's a big challenge, of course, to bring these together in the short perspective.
Maybe we take one more question.
Please.
I'm trying to understand the economics. Did I understand you to say it takes about 110 euros per ton of carbon to make BECCS cost effective?
No, and this is also a very good point. As with the biomass, as with many things when we're speaking about energy systems, you could find a system with very low cost and a system with very, very high cost. The Swedish systems for BECCS are very expensive in international perspective. So they would cost perhaps $110 to do the Swedish case scenario, $110 per ton. Whereas if you do this in Decatur, where you have the first large BECCS demonstration, we are down to perhaps $30 per ton.
Of carbon, not CO2.
Of CO2, yes. This is CO2
Okay,
equivalent.
thank you.
Yes, thanks.
Okay, please join me again in thanking
Thank
Henrik
you.
one more time.